70-742 Lesson 4, Configuring Service Authentication and Account Policies. So what are we talking about here? We're talking about creating and configuring service accounts, group managed service accounts, configure Kerberos constrained delegation, SPNs, server principal names, configuring virtual accounts, domain and local user password policy settings, configure and apply password setting objects, delegating password setting management, configuring lockout account policy settings, Kerberos policy settings within group policy, amongst our topics. So first and foremost, let's talk about authentication. We've touched on authentication a number of times. We're going to touch on it again. Authentication is the act of confirming that you are who you are, or that a system is that system. It's the act of confirming your or your system's identity. And it's an essential part used in authorization. Because remember, once you authenticate, that authentication proves who you are, and your identity is tied to sets of permissions and rights. So that is authorization. What are you authorized to do once you have authenticated? Because it is so key to our cybersecurity, let alone just basic security, we need to choose the appropriate authentication method. Now there's two types that are used in Windows. NTLM, which is NT LAN Manager, and Kerberos. Kerberos is the preferred. Kerberos does provide stronger authentication. And we can see that right here on this document from Microsoft regarding Microsoft NTLM. And it states the Microsoft Kerberos security package adds greater security than NTLM to systems on a network. And although Kerberos is the protocol of choice, NTLM is still supported. And it must be used for log-on authentication on standalone systems. So we use Kerberos in our domains, but on a standalone system, i.e. your home computer, you're using NTLM. So how does that work? The credentials are based on data obtained during the interactive logon process. Consists of domain name, or in a case of a standalone, your system name, a username, and a one-way hash of a user's password. What's a hash? It's an algorithm used to calculate a one-way value. Let's take a quick look at that, because you need to understand, we've talked about that when you type in your password and press enter, you're not transmitting your password. So here are the steps that present the NTLM non-interactive authentication. And the first step provides the user's NTLM credentials and occurs only as part of the authentication process. So step one is the user accesses a client computer, provides domain name, username, and password. And this is in the case of authenticating to a domain. When you type in that password, the client computes a cryptographic hash of the password and discards the actual password. The client, you, sends your username to the server in plain text. That server in turn generates this 16-byte random number called a challenge. In our text, that we're going to see in a moment, they say 8-bit. And it sends that challenge back to the client. The client in turn encrypts that challenge with a hash of the user's password and returns it to the sender. This is the response. Challenge response. The server sends the following three items to the domain controller: the username, which was transmitted in plain text, the challenge that was sent to the client, and the response received. The domain controller uses the username to retrieve a stored hash of the user's password from the SAM database, the Security Account Manager database. It uses this password hash to encrypt the challenge that it originally sent to the client. They both use the same hashing algorithm, The domain controller creates a hash of the challenge. The client had created a hash and transmitted the hash of the challenge as the response. The two are compared, and if they're the same, authentication is successful. So what does hashing look like? Well, let's take a look. From the Microsoft Store on your Windows 10 computer, you know, that little shopping cart, shopping bag that nobody uses, you can get the simple checksum calculator. And in this case, I've taken our ACE IT Lab password and I've typed it in and I've said to use the MD5 algorithm, which is one of the ones that's typically used for NTLM, and I hit calculate. And this is the resulting hash string. The definition of a strong hash is a small difference results in large change. If I were to add the number 1 on the end, watch the hash. Completely different. You can see the difference here. If I were to get rid of the number 1 and calculate again, the hash is exactly the same. If I change, you say, well, you added more characters. I'm going to change O to 8 and calculate. Again, small difference results in drastic change of the calculated hash. That's strong hashing. But that's how hashing works. But remember, it's a one-way calculation. You can't take this hash and determine what the password was. Okay, let's get out of that. Okay, and I'm going to close out of here. We've got our textbook open here. Let's jump back over to our PowerPoint. Okay, so that's NTLM, and it's part of our integrated single sign-on. It provides maximum compatibility with different versions of Windows, and it's easier to implement than Kerberos. We wouldn't even realize that if we didn't see that written down. Because when we install our domain controller, when we install our domain, create our network, we don't even realize it. Kerberos is a computer network authentication protocol. It allows hosts to prove their identity over a non-secure network in a secure manner. It provides mutual authentication, so both the user and server identify each other's identity. This is why it's stronger. What is an SPN? A service principal name. Let's take a look in your textbook. An SPN is the name by which a client uniquely identifies an instance of a service. The client locates the service based on the SPN. And there's 3 components to an SPN. The service class, such as like HTTP, HTTPS, or maybe SQL Server, or maybe SSH. The host name, where that service is at, and the port. Here you go to establish an SPN for HTTPS //portal.consoko.com on port 443. You use http/portal.consoko.com /443. There is your SPN. Class, hostname, port. So let's talk about services. On our Windows desktop machines, we run applications. Maybe games, maybe applications, Microsoft Word, our browser for browsing the internet, and so on and so forth. Servers run services. Servers are most efficient running things that run in the background. It's a program, a service is a program that runs in the background on a Windows system. And it provides a function or a network application or can help the operating system to run other programs. We do have the services console, and we can access that simply by doing a run dialog and typing in services.msc. And there is a list of the running, not running, and what type of services are on and what the startup type is and how they log on. You've got running services that are automatically started when you turn the computer on. You've got running services that are automatically started after the computer's turned on. Delayed start. They don't have to be running for the computer to work. You've got some services that are disabled, and then you have a number that are manually started. They may be started by another process, or not at all. They may not be even used. Now, you can also get the services through computer management, tools, computer management, and then in our list on our left-hand column. Let's talk about managing service accounts. You've got a user account that you use to log onto a computer. Your password expires, you set a new password, and you continue on. A service account is an account under which a service, an operating system, a process runs. It allows the application or the service specific rights and permissions to function while minimizing the permissions required for the users using the application server. Examples of where service accounts are used are Microsoft Exchange, SQL Server, IIS, SharePoint, all examples that need to have services running or and configured with a service account to operate them. If you had a service that had to be given permission for how it provided services to the network, and you used your own personal account, well, 45 days later, your password changes. You change your password and everything's working fine. You're cruising right along. Well, what you forgot was that you had set your old password on how that service can run using your account. All of a sudden, you got users calling up going, hey, this isn't working. I can't access this or I can't do this. Something on the network's broken. Well, that's because the password that was typed in for your account to run the service expired, and you forgot to update that password. So you don't want to use a standard user account. Let me rephrase that. You don't want to use a user's account. Here again, typically with user accounts, you specify how often a password gets changed. And in example, every so often, user logs on, they're prompted to change their password. With a service account, there is no interactive logon. In fact, we'll look at how we configure that service account that it can't be logged on to. You can't use it for logging on. So there's nowhere for you to configure not to expire. So because of that, you have to configure the password not to expire. Now understand, anytime you've got an account that has a non-expiring password, you've created a vulnerability. Part of the reason you have passwords expire is because it takes time to crack a password. If someone is trying to crack a password using brute force on your Windows system, and they're trying to do it by guessing username and password combination, if they do it too many times too fast, they're going to get locked out of the system. And then they have to wait for the lockout to expire. This type of brute force, yes, it's a brute force, but it's done very slowly. By configuring an expiration on passwords, you help to defeat that. Let's take a look. When we're configuring a service account, make sure it's a unique account to run each service on each server. If possible, set the account up as a local account rather than a global domain account. Now, some services you may have to specify a domain account, but if it's possible to run as a local account, do so. Make sure you're using a very strong password for the service account. Now it says make sure that the password changes often. Well, if you change the password for the account, you also have to change the password for the services or application that use the account simultaneously. So we'll look at how you can do that. Make sure that you're giving that account the very, very least amount of access. Remember, only have the rights to do what's absolutely necessary. Principle of least privilege. And whatever you do, don't share the password. In fact, don't even share the service account name. And make sure that you're storing those passwords in a safe location. And when we talk about safe location, not just somewhere where nobody can normally get to, but make sure that storage is encrypted. So in your text, they go through the steps to create a service account. And I want to point something out here on the next slide. In step number 10, it says if you don't want the password to expire, click the password never expires option. Now that goes against what they just told us and what we saw earlier. What we saw earlier was say don't let it expire. And then just a moment ago we read that it should expire, and here they give us the option, well, if you don't want it to expire, check this box. What is it? Well, we'll take a look at that. And specifically, we'll be doing that in the lab. Let's talk about virtual accounts. Virtual accounts were introduced starting with Windows 7 and Windows Server 2008 R2. So more specifically, Windows 7 SP1. A virtual account's an account that emulates a network service account. And it uses the name NT service / fill in the service name. It has simplified service administration, including automatic password management and simplified SPN management. So here is that key. Automatic password management. Let's speak briefly about MSAs, Managed Service Accounts. Also introduced with Server 2008 R2. Their Active Directory MSDS-Managed Service Account object class. And that is what enables automatic password management. Okay, you were going to be looking at that. So for example, let's take a brief look at the step-by-step. You're going to do this again in the lab. But you go into Services. You're going to do the Log On tab for a service. You're going to click this account. This is to use an MSA with a service. You're going to clear the password and confirm. You click OK because you're using an MSA. Okay, different steps. You can have group managed service accounts. The MSA managed service account can only be used on one server. So if you're running in a cluster and you need to have the system or app service under the same service account, you can't use an MSA because that is being distributed across your cluster. So you would use a GMSA. They can be used on multiple servers at the same time. Let's talk about account policies. Group policies. I love group policies. Let's get this out in the open. Let's make it clear. I love group policies. I think this is just one of the greatest things that there is in Windows Server. You can do so much with group policies, it's just unbelievable. It is truly one of the most powerful features of Active Directory. You can use it to control the working environment for user accounts and computer accounts. They give you centralized management and configuration of the operating systems, applications, and user settings in your Active Directory environment. And we do that through what's called GPOs. GPOs are collections of user and computer settings. One of the most basic ones in our default domain policy is a password policy. That's what we do in a default domain policy, is set our password policy. Make sure that it's at least 7 or 8 digits long. Make sure you're using complexity. Make sure it does expire, has to be reset. Specify the number of unique passwords that have to be used before you can repeat a password, and so on and so forth. And then they go in and they tell us the different ways. In that password policy, you'll also specify lockout settings. How many times can a user type in the incorrect password before being locked out? If a user does get locked out, how long are they locked out? If they're locked out, will the lockout expire, or do they have to call their help desk to get it unlocked? There's a number of different settings, and you want to be thoroughly familiar with these. We'll look at that. Sometimes you need to have different types of password policies for different users. In a situation like that, you can use what's called a fine-grained password policy. Typically, we've got one default domain policy, and it applies across the board. Everyone has the same password policies. However, it doesn't have to be. For example, you may prescribe a fine-grained password policy, and this allows you to specify multiple password policies within a single domain. So you can apply different restrictions for password and account lockout policies to different sets of users. For example, you may have users that you want to have an even more restrictive policy. This allows you to have more than one password policy. If you're going to do this, you have to be running at the domain functional level of at least Windows Server 2008. So what is the goal of all this that we're talking about? The goal is confidentiality, integrity, and availability. The CIA of cybersecurity. We call it the CIA triad. When we design these password policies in these different types of accounts, we're working to provide authentication, authorization, and ensure confidentiality. Authentication represents the way that our users, our computers, our processes prove their identity before they're allowed to connect to your network. Once they are allowed to connect to the network, authorization determines what they can do. And the concept of confidentiality is preventing people from reading information they're not authorized to. In other words, just not being able to disclose information that shouldn't be. Authentication, authorization, confidentiality. Additionally, here we go, integrity. Integrity, their definition is the ability to guarantee that the information has not been arbitrarily changed from the time it was sent from the original source and received by the other party. What does that mean? If I send you an email, integrity ensures that you're going to get my original email, that nobody has been able to intercept it and change the contents of that email. Or if you're going to access a network resource, that you are accessing the authentic resource. Non-repudiation. The concept of non-repudiation is not that you cannot deny that something came from you. It's the method used to provide proof that a security principal, user, computer, or process is the source of data. For example, if I sign an email using a digital certificate, that provides non-repudiation. Only I hold the key to sign that digital certificate, so the email must have come from me. Non-repudiation. We can use two-factor authentication to strengthen our authentication. You say, well, I've got a username and a password. Well, that's single-factor authentication. These are both what we say is something you know. I know my username, I know my password. However, if we incorporate biometrics such as a fingerprint or a retina scan, that's something you are. Now we've introduced a second factor, something we know. What about if we use a smart card? That's something we have. Here's a third factor, something you know, something you have, something you are. This is the concept of multi-factor authentication. Who has ever authenticated to a game and had to receive a PIN to type in before they were able to access the game? I get it all the time when I log into infraguard.com. If I want to be able to check out the latest Homeland Security and FBI releases, I log on. It says we need to send you a PIN, verify your phone number. I verify it. It sends me a PIN. I have to type that PIN in. Two-factor. Additionally, how do we support authentication and authorization? Through the use of digital certificates, and we've given examples. I just did. Using a certificate authority. In the case of our websites that we utilize on a daily basis, those certificate authorities are a third party. You never sign your own certificate to verify the authenticity of your website. It's done by another organization. Biometrics, we can use Windows Hello. So in this lesson, we talked about authentication. We talked about the difference between NTLM and Kerberos, what a SPN is, using different types of service accounts, the managed service account, the group managed service account, using account policies, password policies, lockout settings, how a fine-grained password policy can be beneficial to organizations. And we've wrapped it all up by going through the different areas that help to strengthen our authentication and authorization, and really putting together the confidentiality, integrity, and availability aspects of a network. This has been 70-742 Lesson 4. Thank you.